Hi, it's Jason Shepard again. Hopefully by now you've had a chance to watch the introduction to this overall virtual demo experience. We talked about LF Edge and the high-level solution architecture, and then also hopefully watched the Fledge demo that Ashwin presented around vibration monitoring using Fledge. And this module will talk a little bit about Project Eve and its role in the overall solution. So, what is Project Eve as part of LF Edge? Open source project. It's all about creating a universal edge computing engine for IoT workloads as part of the smart device edge. We talked about the taxonomy a little bit in the introduction, and we definitely recommend checking out the white paper online from LF Edge. Universal abstraction layer to make it easier to deploy and orchestrate hardware and applications on distributed hardware. So this is hardware that is outside of a data center, could be on a factory floor, out in a wind turbine, on an oil well, in a retail store, any number of locations. Hardware that's still capable of running apps. So about 256 megs of memory at the lower limit. That's about as low as you can go before you can't support that abstraction layer for virtual machines and containers, up to a small cluster of servers, but still deployed outside of a data center. It's all about providing this flexible foundation, and very, very important is this notion of it enabling an open API to where whatever controller that you want to use with Eve, it's your choice, but you're not going to get locked into one choice. And so that open API driven by the vendor neutral project is super important. So why Eve? So the moment you get out of physically secure data centers, and we've got a lot of great assets, a lot of great companies doing things in data centers. Once you get out of a physically secure data center, it gets much more diverse in terms of the hardware types. It makes it of different ARM and x86 architectures. You've got a lot of legacy out there. You've got different domain expertise required for various different use cases. So really lots of diversity to manage. And so having more of a common foundation is very important. Also, you have a massive scale to contend with. You've got lots and lots of different nodes distributed all over the place, and you need to be able to secure those across different geographies. And as part of that security question, there's no perimeter here. I mean, there's no physical perimeter like you have in a physically secure data center. You don't necessarily know what network those devices might be deployed on. You don't know if there's a firewall. So it's really important to take a zero trust security model, overall approach when you're focused on, IoT edge compute. And so what we need is more of a standard foundation that's super flexible and open and gives you that ability to just focus on the value versus that foundation. And think of Eve at the smart device edge, which also includes PCs and tablets and mobile devices. But those are solved problems, very well established ecosystems. But in the IoT sense of workloads at that edge, very, very diverse and fragmented. And so think of Eve as doing for the IoT workloads at that smart device edge what Android did for mobile. Create a consistent base that people can build ecosystems around, different applications on top of that foundation, very much around also dealing with that fragmentation element. So we're comfortable down to about 512 megs of memory today with Eve, plus your choice of applications. And of course, how much memory you need depends on the applications. The lower limit is probably around 256 megs, but it's all about that abstraction. A lot of different approaches, but we think that Eve is the best balance of compared to some solutions out there today have a proprietary bare metal abstraction layer, which is able to provide you some of those benefits around security and networking and making sure that you don't brick the device out in the field because you've got that lower level access to hardware. But they're proprietary, so as a choice, you are going to get locked into that controller that works with that abstraction layer. And then there's various data center options that don't really work for IoT edge hardware. They rely on more resource capable devices. And then you've got agent-based approach, where you use that with your choice, with the controller, but at the same time you're running on your choice of OS. And if you don't integrate that agent with the OS, you can create issues with potentially bricking that device out in the field. You might have lower level security challenges. You need to harden that OS to make it work really well from a security standpoint, and then tie the agent into the OS. And if you do all that work, well, you've just built Eve. So, the proposal here from the community is, let's go standardize around Eve as that bare metal foundation, and then you take your pick of applications and you make it work with whatever hardware that you want to work with, and the like. So it provides much more scalable base for your compute at this edge. And so we see a variety of different deployment models. The demo that Ashwin ran through with Fledge is sort of like the first one, where I take an application stack, I'm pulling data from existing systems. And he didn't talk through, but it could be legacy systems as well as the vibration sensor that he mentioned. Pulling it in and then sending it to your choice of backend. So that's kind of a traditional workload consolidation use case. We also see Eve being used with edge hardware to be deployed out for secure proxy of data, using the distributed firewall capability. Maybe it's from a wind turbine, trying to get data to my cloud securely over a wide area network. And so I'm using Eve on a edge compute node that's buried within inside of that wind turbine. And I think an last use case would be where I take a compute node running Eve and I deploy various different services, whether it's for analytics or security. It could be OT protocol inspection, intrusion detection, etc. And I'm running it out of band with the network traffic, off of a span port. So I'm monitoring traffic as it goes by and looking for different things using a variety of different tools. So we see all kinds of different deployment models for Eve, and really many different verticals. And as a recap, so the solution architecture that we presented, talked about this in the intro, but basically Eve is that lower level foundation, gives you access to your choice of hardware. You can use it with your choice of console, and then any application stack on top. In this case, we're using Fledge. Together they provide this sort of universal foundation for pulling data out securely and putting it into whatever, transforming it and putting it into whatever on-prem or cloud system you'd like. And then Eve, as part of that, enables you to run virtual machines right next to any number of containers as part of the overall solution. And then, of course, the open API within Eve keeps it to where you don't get locked into any particular backend, and it could run on a gateway or even a server depending on the need, but very much focused on that distributed element of the overall edge continuum. And so definitely check out the demo if you haven't already, is for more on that. And then also take a look at there's some Fledge information within the overall demo area. Go check out LF Edge on the broader in the broader sense, on the website. Lots of information online, and feel free to reach out to the community if you have more questions about any of these projects that you've seen within this overall demo experience. So with that, I appreciate you for listening, and definitely reach out if you have any questions. All right, thank you.